Hello and welcome to section 6.7, which is on polygons in the coordinate plane. So we are going to use three main ideas that we've done previously and put them all together in this section. The first one is the distance formula, which I have written there to remind you what it is. The square root of x squared minus x1 squared plus y squared minus y1 squared. Triangle DEF has vertices of D, 0, 0, E, 1, 4, and F, 5, 2. Is triangle DEF scalene, isosceles, or equilateral? So obviously there's a couple different ways I could approach this. I could go ahead and graph it and then do the distance formula, but I'm going to have to do the distance formula anyway for all three sides to see if they're all three equal, if two are equal, or if none are equal. So I'm just going to go ahead and do that. So I'm going to do D and E first, so these two. So square root of 0 minus 1 squared plus 0 minus 4 squared. So that would be negative 1 squared plus negative 4 squared. So 1 plus 16. Square root 17 for those two sides. Then I'm going to go ahead and do E and F. So 1 minus, and keep in mind this is all under the square root symbol. So 1 minus 5 squared plus 4 minus 2 squared. So 1 minus 5 is negative 4 squared, plus 4 minus 2 is 2 squared. So 16 plus 4, square root 20. So I don't have any equal so far. So then I'm going to do D and F. So 0 minus 5 squared plus 0 minus 2 squared. 0 minus 5 is negative 5. Negative 5 squared is 25. 0 minus 2 is negative 2. Negative 2 squared is 4. So square root 29. So I have three separate answers, three different answers. So the answer to the question is that triangle is scalene. None of the sides are equal to each other. So just for a reminder, the slope formula, we define slope, you do y2 minus y1, and it has to go over the top of x2 minus x1. We should know that, but just in case we need a reminder. Quadrilateral MNPQ has vertices of M, 0, 1, N is negative 1, 4, P is 2, 5, and Q is 3, 2. Is MNPQ a rectangle? Explain. Again, could I graph this and then do the distance formula and say if I have two equal sides and two equal sides? I sure could, but I'm going to go ahead and find the slopes of all of them and do it that way. So I need to find the slope of all four sides. So the first one I'm going to do is M and N. So so 4 minus 1 over negative 1 minus 1. 4 minus 1 is 3. Negative 1 plus negative 1 is negative 2. So negative 3 halves is my, no shoot, this should have been a 0 here. So the slope of that one is negative 3. Then I'm going to go ahead and do N and P. So 5 minus 4 and 2 minus a minus 1 plus plus. So 5 minus 4 is 1 and 2 plus 1 is 3. So 1/3 is that one. Then I'm going to go ahead and do P and Q. So 2 minus 5 and 3 minus 2. 2 minus 5 is negative 3. 3 minus 2 is 1. So that slope is negative 3. Ooh, I have two sides equal. I wonder if that's good information. Then I have, which one do I have left? I have Q and M left. So 2 minus 1 and 3 minus 0. 2 minus 1 is 1. 3 minus 0 is 1/3. Ooh, looks to me like these two and these two are the same. What does that mean? That means that these two sides are parallel and these two sides are parallel. Well, that's good, because in a rectangle you would need two sets of parallel sides, but it still has not proven that it's a rectangle. All it's proven that I have is two sets of parallel sides. But if I look at those sides, what do -3 and 1/3, what do those two slopes mean? They are opposite reciprocals, so that proves that the sides are perpendicular, which would make right angles, which would mean that, yes, it is a rectangle. And your explanation would be that opposite sides are parallel and adjacent sides are perpendicular. So yes, that is a rectangle. The midpoint formula, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So this problem here is rather lengthy, but it's using all information that we've already learned. So an isosceles trapezoid has vertices of A, 0, 0, B, 2, 4, C, 6, 4, and D, 8, 0. I have already graphed that here for you. You can see there that that is an isosceles trapezoid. The question says, what special quadrilateral is formed by connecting the midpoints of the sides of AB, ABCD? So I should have probably marked here which sides were which. This is A, B, C, and D. So I need to find the midpoint of all four sides. So I'm going to go ahead and do AB first. And I'm going to use this formula right here to do so. So 0 plus 2 divided by 2, and 0 plus 4 divided by 2. So that midpoint is 2 divided by 2, which is 1, and 4 divided by 2, which is 2. So 1, 2 is our midpoint. So 1, and I'll put those in a different color. We'll go yellow. So 1, 2 right here is our midpoint. It doesn't show up very well. Let's go green. Shows up a little better. Got to make it a little bit messy to show up there. So there's our first midpoint. Then I need to do the same thing for all the other sides. So I'll do BC next. So 2 plus 6 divided by 2, that's 12 divided by, or excuse me, 2 plus 6 is 8. 8 divided by 2 is 4. Then 4 plus 4 divided by 2, so 8 divided by 2, guess what, it's 4. So my point is 4, 4 for that midpoint. So I can go ahead and put that point down here. 1, 2, 3, 4, and 4 up is right there. I need to do the other two sides yet. So I'm going to go ahead and erase this so that I have more room, so I don't have to go way down the page. So now I'm going to do C and D, so side CD. So 6 plus 8 divided by 2, 14 divided by 2 is 7. 4 plus 0 divided by 2 is 4 over 2, which is 2. So our point is 7, 2. So 7, 2 is right there. And then I still need to do AD. So 0 plus 8 divided by 2, 8 divided by 2 is 4. And I have, for my other one, I have 0 plus 0 divided by 2. So guess what? It's still 0. So 4, 0 is my last midpoint right there. Okay. I'm going to connect my lines so that you can kind of see what's going on. Keep in mind this is kind of messy to do on here, but you should be able to see what's happening. Okay, so I have a quadrilateral inside of my trapezoid. Now I can assume that I know right now what it is, but I can't really tell for sure. They appear as though they might be equal, but I don't know unless I actually figure out if they're equal. So now I have to go ahead and take my distance formula and see if all my sides are equal to each other. So now I need my other two sides, which I erased, but A was 1, 2. This is D. This is the midpoint of AB. I guess I should write it like that. This was the midpoint of CD. Take that back, that was AD. 7, 2 was C to D, and my B to C is 4, 4. So I need these 4 to do my distance formula. So the first thing I'm going to do is, let's do the A to the B. So I'm going to do this one to this one, this side right here, using these 2 points. Distance formula. So I have to go back to this formula. So 1 minus 4 squared plus 2 minus 4 squared. 1 minus 4 is 3, negative 3 squared is 9. 2 minus 4 is negative 2 squared is 4. So square root 13 is from here to here. Then I'm going to do from, I'll go ahead and do, I'll just go around, we'll go C to D. So I'm going to use these 2 points, the 4, I'm going to use the 4, 4, which is this one, and the 7, 2, which is this one, these two. So 4, 4, and 7, 2. So 4 minus 2, I better do the x's first, since that's how I did my other one. So 4 minus 7 squared plus 4 minus 2 squared. 4 minus 7 is negative 3 squared is 9. 4 minus 2 is 2, 2 squared is 4. 9 plus 4 is square root 13. I'm seeing a pattern. So I have 2 answers that are square root 13. Again, I'm going to go ahead and erase this so that I have room to continue writing my other 2 so that we can still see the picture. So we just figured out that both A to that side and that side are both square root 13. So now I'm going to do this side to this side, which is the, and I'll write it up here, the 4, 0 point and the 7, 2 point. Okay, so 4 minus 7 squared plus 0 minus 2 squared. 0 minus 2 is negative 2 squared, which is 4. 4 minus 7 is negative 3 squared, which is 9. And 9 plus 4, guess what? I get negative square root 13 again. I wonder if that fourth side is also going to be negative square root 13. The last side I need to do, so the side we just did was this side. What we have left is this last side here, which is 1, 2, and 4, 0. So 1 minus 4, ooh, looks like a common theme again. 2 minus 0 squared. 1 minus 4 is negative 3 squared. Negative 3 squared is 9. 2 minus 0 is 2, and 2 squared is 4. I get square root 13 again. So I have just proven that all 4 of those sides are equal, and they are definitely not 90-degree angles. So 4 equal sides, 4 congruent sides would make it a rhombus. So that was rather involved, but using all the math that we have learned so far, you can get to the answer. You just have to be willing to do the work. So bring that knowledge with you, and we'll talk about it more the next time I see you. Have a good night.